Now we want to talk about another product, the cross product of two vectors. And we're going to, the cross product only occurs in 3 dimensions. It doesn't occur in the plane. It doesn't occur in higher dimension. It occurs only in 3 dimensions. The cross product then requires that we have vectors that represent each of the 3 dimensions. It doesn't actually require it, but it's very convenient to have unit vectors in each of the directions of each of the 3 rectangular coordinate axes. The I vector in the direction of the x-axis, the j vector in the direction of the y-axis, you're familiar with those, and then we have a z-axis perpendicular to the x and y-axes, and maybe I should draw a little indication here that these 2 are perpendicular, and of course this one is perpendicular z-axis to the x-axis and to the y-axis here and to the x-axis. In any case, the k vector is a unit vector, vector of magnitude 1 in the positive z direction. Okay, now there are various ways of defining the right-hand rule. And this is the most common way, but I'm going to define it this way anyhow, because, well, reasons I'll maybe explain as I go. But for now, just accept it. This can be taken as a definition. It's completely consistent with any other definition. Okay. First of all, we use the right-hand rule to define the cross product of I, j, I with k, and j with k. And then we have a rule that says reverse the order. If we do j cross I, it's the negative of whatever we get for I cross j. And there's also a rule for I cross I, j cross j, and k cross k. And once we've established these rules, the cross product of any vector is defined in a way that we'll see. Okay, now, the right-hand rule simply says, and I'm going to have to move over here, if I put my fingers in the direction of the I vector and turn them towards the, well, let's imagine we have an xy plane here, I, j, k. If I put my fingers in the direction of the I vector and turn them toward the j vector, my thumb is pointing upward, and that's going to be in the positive k direction. So I'm going to say that I cross j equals k. Now, you should try this. Imagine again an xy plane in the is horizontal, x in this direction right toward the camera, y in that direction, and the z direction upward. If you do the same thing with the I vector, put your fingers in the direction of the I vector and then turn them so that they turn toward the k vector, and I'm not oriented that way right here. I'm just turning my fingers to show you what I mean. You might go back and look at what I did with the I and j vectors and see what you get if you do I cross k. All right, well, I'm going to go ahead and do that, but hopefully you've done it yourself. Here's the I vector, fingers in the direction of the I vector, the positive x direction. Now, if I'm going to turn my fingers toward the k vector, I'm going to have to turn my hand over this way. And now my fingers will turn toward the k vector, which is straight up, and look where my thumb's pointing. It's pointing to this direction, okay? I won't say to the right or left, because as I turn to face the camera, turn back this way, left and right get reversed. But it's going to be this direction. And that's the negative, that's the direction of the negative of the j vector. So that equals negative j. Okay, figure out about j cross k. What do you get there? You should have paused and done that. But, you know, j's in this direction, and k, I have to turn it this way, and my thumb is pointing at the camera, which would be the positive x direction. So that's going to equal I. And now we can conclude that j cross I would be negative k, k cross I would be the negative of negative j, so it would just be j, and k cross j would be negative I. And the other thing is I cross I equals j cross j equals k cross k. They all equal 0. Well, I'll just go ahead and write the 0 vector in for each of these. Each of these, it's a vector, but it's the 0 vector. Okay, well, that defines the cross product completely, but it doesn't give us a good grasp of how it behaves. Now, I'm not going to go through a recitation of all the properties. Again, I'm reviewing something you're supposed to already know, and this is covered in the first chapter of a university physics text. But I'll just say most of the usual rules of algebra apply, but the cross product isn't commutative. Okay, and for example, I cross j equals k, but when we reverse order, we get a negative. It's anti-commutative in that sense. So j cross I then is negative k, not equal to I cross j. But the numbers that we use as coefficients of these vectors do behave in the usual fashion, and multiplication of the numbers is commutative. Multiplication of the I, j, and k vectors that isn't. So let's do an example. Okay, example, 2i plus 3j. Now that's just a vector, 2i and 3j. We could represent that down here in the plane. And I might actually even draw that when I pause here. And then negative 2j, which would be over here, plus 5k, which would be up here. That would be a vector here in the yz plane. So we'd have a vector in the xy plane crossed with a vector in the yz plane. Now, when we do the cross product, the usual rules of algebra apply, meaning we have a distributive law here. So again, we're going to have 2i cross negative 2j, and 2i cross 5k, and 3j cross negative 2j, and so forth. You ought to write that out and speculate then on what we get from each of those calculations. In other words, how far can you go with the calculation of the cross product using the distributive law and a little bit of common sense. Of course, common sense can be misleading, but we'll try to confirm that. Okay, now you can see here 2i plus 3j. That would be 2 i's, that would be about here, and 3 j's would be about here. So if I add 2i and 3j, I get this vector. Negative 2j would be 2 of these back in this direction. That put us about here. And 5k would be 1, 2, 3, 4, 5 of these, probably actually a little more than what I drew, but I ran out of board space. But you get the idea. So right there is negative 2j plus 5k. So I can label these vectors 2i plus 3j, negative 2j plus 5k. Now, applying the distributive law here in the obvious manner, and I, again, haven't stated those laws, so I haven't proven that that's what we would get, but we get 2i cross negative 2j. And then we get 2i cross 5k. And, of course, we're adding that. And then it's going to be plus 3j times negative 2j, crossed with negative 2j, and 3j cross 5k. Now, what do you think each of these would be? What do you think 2i crossed with negative 2j would be? And what do you think each of these would be? Well, I'm not going to pause but for a second, but you ought to pause the video and figure that out if you haven't already. Okay, and again, we haven't stated the laws, but what we would expect, and that expectation would be correct, is we multiply the 2 by the negative 2 to get negative 4. And then we're going to have I cross j. In other words, we bring our numbers or our scalars out of the product, and then we just multiply our two vectors, okay, the I cross j. And of course, negative 4i cross j, well, what's I cross j? It's k. So that part of it is going to be negative 4k. Now, if you haven't done the rest of these, you ought to do it. It's better to do it and then see it. And of course, if you know this very well already, it wouldn't be necessary. If you can do it in your head, that's fine. But you ought to have an image of what I'm about to get. Okay, 2 times 5 is 10. I cross k is what? Let's see, I cross k is negative j. And of course, you don't necessarily have to look back at a list. You can just say, okay, let's see here. I cross k that direction, that's negative j. Okay, that works. So that's times, and I said I cross j, didn't I? Okay, forget what I said just now. We should have an I cross k. Something's wrong here. Never mind. Thought I made a mistake and I didn't. Okay, it is I cross k. Moving back and forth on the board, I get easily confused. Apologies. 2 times 5 is 10. I cross k, as we just saw, is negative j. And I started to write down negative k. I might have even said negative k, but it's in this direction, and that's clearly the negative j direction. Okay, 10 times negative j. And then we're going to have 3 times negative 2, which is negative 6 times what? J cross j. Well, j cross j is 0. And then we're going to have 3j cross 5k. That's going to be 15. And j cross k is I. So that's going to be 15I. Okay, well, simplifying that, 4k minus 10j plus 15I. Now it's conventional to write these in the order I, j, k, so it's going to be 15I minus 10j minus 4k. And of course, we could also write that as the vector 15, negative 10, negative 4. Now, it turns out that this vector is going to be perpendicular to both this vector and this vector. Now, to show that it's perpendicular, it's sufficient to show that the dot product of two vectors is 0. Because the dot product is magnitude times the cosine of the angle between. If you get 0, if the two magnitudes aren't both 0, means the cosine of theta has to be 0, so that theta has to be 0. That the cosine of theta is 0, meaning that theta is going to be 90 degrees or pi over 2 radians. Okay, sometimes I get in a sequence of words and continue on it. So we'll be more thorough about that, but here's the vector that we got for the cross product. Let's just cross that with our 2i plus 3j vector. Now, did I say cross? Dot. We're dotting the two vectors. Dot this vector with this vector. Now, the dot product is just going to be, well, I component times I component, j component times j component, k component times, what the heck, where's the k component? Well, this is a vector. Now, this vector is embedded in three-dimensional space, and it has a 0k component. It has no component in the direction of the z-axis, so that's going to be plus 0k. That's not OK, that's 0 times k. Probably ought to put a multiplication sign in there, but you'll understand what we mean here. So when we write that vector down, we write it this way. Okay, well, that's going to be 15 times 2 plus what? Negative 10 times 3 plus negative 4 times 0. And that, I'm sure you can do that, arithmetic does equal 0. Implication. Cosine of theta is 0. So theta is a right angle or 90 degrees. Okay, so there's a test, and you could do the same thing with this vector. You'd have to put a 0i in there if you want to match up your I components to multiply them, but you're going to get the same result. So, at least in this case, this cross product is perpendicular to both of the original vectors.